and welcome to this session where we are now going in details on set theory. And in today's session, we're basically going to look at the operations on sets. This is the most interesting part under the set theory. Now, the same way we do operations on numbers. Suppose you have the number 2 and 3. We can perform an addition operation where we are going to add the number 2 to 3. Or we can perform a subtraction operation where we are going to subtract a 2 from a 3. The same way we are able to do these operations on numbers is the same way we can do operations on sets. So there are basically 3 operations that we do on sets. And the first operation is what is known as the union. So let's look at the definition. If you're having 2 sets, you have set A, you also have set B. Remember these 2 sets, they contain elements. These 2 sets, they contain elements. But the union of set A and B, denoted by this symbol here. This is what is used to denote the union, which you can also call as a cup. So the union denoted by A union B, this denotation, is the set containing all the elements of both A and B. So remember from the beginning, we started with the set A and the set B. Now, when you perform the operation union, you are going to have the third set. And this third set is what is denoted by A union B. And we are saying what is going to be in this third set are the elements that are in both set A and set B. So if you are having the elements in here 1 and 2, here you're having the elements 3 and 4. By definition of the union, we are saying it is the set, the third set, that is going to contain all these elements in A and in B. So the A union B you are going to have is going to be a set of 1, 2, 3, and a 4. So mathematically, it is defined as A union B is the set that contains an element X, such that this X is coming from the set A or it is coming from a set B. That is the definition of a union. Remember, we are combining all the elements. So it is either it is in set A or it is in set B. So the definition of union goes with the word or. We are looking at the elements that are in A or the elements that are in B. Put them together. That is the definition of the union. We can go to the other operation, and that is the intersection. So this is the second operation done on sets. So if you relate this with numbers, you can tell that this first operation that we had as the union is adding the elements that were in set A and in set B. So you can therefore relate this operation to A plus, the union. You are combining the elements under the sets A and B. So the second set, or the second operation we are talking about is the intersection. So the intersection of 2 sets A and B, again we are talking about 2 sets. The intersection between set A and B, denoted by A and the cup, which is written as KAP. Remember the first one was the cup with U in between. Now for the intersection, we are using this cup. So this is the set. Again, remember it is the third set we are talking about. We are dealing with 2 sets here, set 1, set 2. So the third set is what is called the intersection. So this is a set containing all elements that are found in both A and B. So the key word here that we have is both A and B. Now, what is the difference between of both A and B or in both A and B. This is the key words that we have. For the union of both A and B, that implies that you are looking for the elements of set A and of set B. But when we say in both A and B, what we imply, you should have a common element that is found in set A and in set B. Mathematically, this is how we define the intersection. So this is your third set, A intersection B. So this set is having an element X, such that this X should be in set A. And again, this is the keyword you should take note of. And this element should be in B. Unlike where we were saying O. And this implies that this element should be automatically in A and in B. For example, if we have our set A to be 1, 2, and 3, we also have our set B to be 2, 4, and 5. So when you look at these two sets, we are looking for the element X such that this X is in set A, and the same element X should be in B. The element that we are having between these two sets to be the intersection is the element 2. We have 2 that is in A, we also have 2 that is in B. That is what it means by intersection. I hope we are together. We can now go on to the third definition. And the third definition is the complement of a set A. What is a complement of a set A? And this complement is what is denoted by A to the power C or A prime. So what operation is this? So this is the set of all elements that are not in A. When we say A complement, we are implying or we are looking for the elements that are not in the defined set. If we say B complement, we are looking for the elements that are not in B. Therefore, mathematically, we are going to say the A complement is a set with an element X. So in A, you are having an element X. In A complement, there is an element X, such that this element X, quite alright, it is under the universal set, but it is not in the set A. Remember, we said all the elements that are under discussion, they should fall under the universal set. So you can have this to be your universal set containing only one set A. Set A has 1, 2, we have a 3 outside set A. So by A complement, we are looking for an element that is not in A. Remember, all elements under discussion, they should fall under the universal set. So if the element is not in A, it should fall outside set A, and this is the universal set. So the element we are looking for here is 3. That is A complement. The complement of a set A, denoted by A complement, is the set of all elements that are not in A. Quickly, we can look at 1 or 2 examples. Or before that, we have another definition before we go to examples. Perhaps we'll look at the examples in the following session. So make sure you subscribe to get notified when the next session is uploaded. So the other definition we can look at is the difference of two sets, A and B. Remember, when we're dealing with numbers, we say the difference. We are subtracting one number from the other. But that is not the case with difference of two sets. So the difference of two sets denoted by A minus B. So this is another set. Is the set of elements which belong to A and which do not belong to B. Let's write that mathematically. So we are saying that in this third set, we should have an element x. This element x should be in A, but it should belong to B complement, meaning it is not going to be in set B, that is A minus B. So now you can as well rewrite this set builder notation as x belong to A, so you are going to have an element in A. Remember from the definition of intersection, this is where we were applying AND. So AND goes with intersection. We are saying x should belong to B complement, so it will be A intersection B complement. Remember, the element x is not supposed to fall in set B. It should only be in A. Remember, by definition, where we said in, so it should be in both A and B complement. By complement, remember, we are looking for the elements that are not in set B. So this is the definition of the difference of two sets. Make sure you like, subscribe. In the next session, we are going to look at 1 or 2 examples under the operation of sets.